Hi everybody, welcome to the Full Stack Grind, where we focus on making modern applications. Today, our problem is as follows. I have an application that is running in an AWS EKS cluster. The application, in this case, wants to read out of a DynamoDB database. But as you can see, I got an error right here. So why can't I read the DynamoDB? The answer is pretty simple. It's because it's not authorized. So today, we're going to learn two solutions on how to fix this. The first one is quick and dirty, and it's easy to do. The second one is a little bit more sophisticated, but it's also not too difficult to do. It's just that it takes a little bit more time, and it's just one of those little tricks that you may not have researched before to find out. Before we get started, let's take a look at our trick of the day, the kickflip. It only took me about 20 tries to get this one. Let me first set this up from scratch so you can see where I'm coming from. I've created a little script because I sometimes like timing how long it takes to create a cluster. In this version, I'm going to do Kubernetes 1.18. I'm calling my EKS cluster December 9th. I'm just going to have 2 nodes just for this simple example. There's some auto-scaling groups in there as well. To create this, all I'm going to do is I'm going to just run this script, and it will go through and create our cluster. And that will probably take between 15 and 20 minutes, depending on how EKS feels today. Well, that took a long time. So 16 minutes, 39 seconds, and we now have a cluster up. Now we just need to create an Ingress controller. You can see all this in my segment, my show notes here. The Ingress controller, I'm just going to use a standard Nginx Ingress controller. So I'll light that up. That'll give me my ingress rules. And now I have to set up the actual, it looks like I need to do the CertManager. And CertManager is just something I have here in my notes. You can take that look at that. And now, Control get namespaces, you'll see that I now have CertManager and I have the Ingress controller. So those are set up, ready to go. And if you look at my actual Ingress controller, get services all namespaces, then you'll see that my Ingress controller is right here and he is ready to go. So if I put this guy now working, it points us to nothing since there's nothing there to show. So, which is pretty much what we expected. Now, what we need to do is we need to take this particular load balancer and we need to associate it with our DNS record. Going over to our hosted zones, we can see the one I actually want to do is the castlerock.ai. So I look in here, and this is the one I'm actually interested in. I'm going to change the record here. I'm going to change it to actually get rid of this old record, which doesn't exist. And this is actually the one that we're looking for. So anything that goes to star.kubernetes.castlerock.ai is now going to go to this load balancer. So I save changes, foobar.k8.castlerock.ai, then you'll see it goes to that Nginx controller. So now our routing's working. Here's a couple of databases I have, but I don't want to mess with those. I'm going to create a new one. So let's go, and I have a Terraform file here called dynamo.tf. And in here, I have it labeled so you can actually see what it is you want to create. But in my case, I'm just going to create one table called Dynamo Users, and it's going to have just a simple key ID and some attributes. And I'm going to insert one record, and that is going to be Mal. You know, Mal of Descendants 3. You know you watch Descendants. You know you do. So anyway, we're going to create that. So let's go here and Terraform apply. This will create our new database. Yes, I do want to create it. Now I look over inside of my databases by refreshing, and we have our Dynamo Users table, and it has Mal, so one ID in there. We now have an application, so let's take a look at that. It's in my app directory. Here you see the main.py, and it's really just a simple Python Flask application that takes one route, which is just the slash route. And what it's doing is it loads up a Boto3 resource. Boto3 is how we communicate with Dynamo and AWS resources inside of Python. And then once it gets that, it sends it over to a render template, which is this index, and then it will go through and display it. Looking at the templates, got the index there. It goes through and it's going to look for all the different IDs. And right here you can see it just loops through them all. And we'll go through and display them for you. One of the things I added in here at the top was that if there is an error, I will actually display the error. So if there's an error connecting to the database, I want that to be shown. So the next thing I need to do is actually wrap this up into a container. So going back down here, I see that there is a Docker file I've created. My Docker file is very simple. Now when I make containers or Docker images, I don't like just running Docker, because if I do that, I'll forget, like, well, what name did I give it? How did I do it? What did I do? I don't remember. So what I do is I make a make file. My make file has two different components. One is the build, which will actually go through and build it, and I'm just going to build it right here. The other one is the push, where I'm actually going to push it up into my ECR, AWS Elastic Container Registry. So that's where the containers will be stored for use, and that keeps it private to my environment. I have this nice command right here, because in order to do ECR, you have to actually run your AWS login. So this right here handles that. So what I can do at this point is I can just do make, and what it's going to do is make everything, and then it's going to push it up to the register. And you can see it already exists because nothing really changed inside of it. If I go over and look at my container registry, which I can do over here, you can see my registry right here. Here's my Docker image. So it's ready to be used. Now that we have our image loaded in the registry, we need to deploy it to our Kubernetes cluster. To do that, we need to create a deployment. We also need to create an ingress. We need to create a service. Let's go take a look at these things that we're going to create. I have this file called eksdynamo.yaml, and what it does is it goes through and creates a config map where we store some information. We have our deployment here. You can see down here that our deployment pulls this image right over here. You also see that we have a ingress, so that if somebody comes to dynamo.k.castlerock.ai, it'll actually route to this particular service. Let's go through and deploy it. Now you can see that there is a pod that it's creating right now. We have our service, EKS Dynamo, our replica set, our deployment, our pods, those are all running. We also have this ingress controller that is working right now as well. Waiting for the pods to come up. There it is. The other thing that we did inside of our deployments is in our ingress controller, we actually told it to use Let's Encrypt to do the TLS. So the TLS secrets are all automatically created and enabled. Dynamo.k.castlerock.ai. You can see right here it says it's not private. Oh, you know what? I actually forgot to deploy something. Back inside of my application stuff, I need a product issuer. There we go. So we got certificates. Now let's see if we have some orders. You can see it's pending. It's waiting to get it. Got it now. Got it. Okay, so let's go back and take a look. Refresh. DynamoDB. Look at that. Now everything here is secure. We've got everything up and running. We're ready to go. But the problem is we cannot access the DynamoDB table from our container. So this is a pretty standard setup so far. We've just set up EKS. We haven't really done anything special. Let's go back to our trick of the day real quick, and then we'll figure this out. So solid. We're going to create a policy, and then we're going to apply it to the node group so that all the nodes will have access to the DynamoDB table. So any container that's running in the node will, of course, then have access to DynamoDB. Let's create a new policy that allows our nodes to be able to access DynamoDB. Basically, this is the action that we need to perform, in this case DynamoDB scan, and then the resource we want to use is just this database that we created. We can just create a brand new one that looks as follows. Here you can see that the action we're allowing is DynamoDB scan, which is all the application wants to do. So now we'll go through and review this policy. We'll give it a name. I'll call it EKS Dynamo Users, just for fun. Okay, I'll create the policy, and now I have that ready to go. Okay, so now that we've created that new policy, we need to add it to the particular node group. Well, who do we need to add it to? If you look back at our error message that it tells us, it's actually looking for this node instance role right here. These are the guys that are trying to be able to perform it. Which is this today right here. It's this node group right here. So I can attach this policy to it, and I can find mine, EKS Dynamo Users. By attaching this policy, it goes in there. And you can see it in here now. So when I refresh, boom, I'm now able to get everything I need from the DynamoDB table. Okay, so what's wrong with this solution? Not much. It works. One thing that we've done really well is we've locked it down so that this permission that we've given is only the scan. So we didn't give it permission to execute on any DynamoDB table. We locked it down so that it can only do that one DynamoDB table. The other thing we did is we locked it down so it can only perform the scan operation, which is all the application wants to do. So that's pretty good. What's bad about it? Well, in this case, the issue is that any pod that runs in our cluster now has access to that DynamoDB table. To perform the scan operation, yes, only, but maybe there's sensitive data that we don't want other applications within the cluster running. And as we want to get to this security-based solution, we want to make it so that our pods can't just go wild out there. I think we want to try to lock this down a little bit more. So what are we going to do? When you access the cluster as a user, you have a set of roles that are presented to the API server that allows you to do some actions. What we can do is we can attach a service role to a pod that allows it to have some actions as well. Now Amazon took this and they wrapped it into IAM, so it now allows, with this projected service account token feature, to wrap up AWS IAM credentials so that the pods can actually go through and authenticate with AWS and then retrieve access to the AWS resources that they want to consume. Let's go back and remove the policy from the node group. That way, nothing in the cluster can access DynamoDB at this point. Going back to my application, if I refresh it, you can see that I can no longer access that DynamoDB users table. It doesn't have permissions. On EKS control, utils, associate, IAM ODC provider. The cluster, its name is December 09, and I approve this action. Of course I do. And so it's going to go through and create that IAM OIDC provider. Next up, we need to actually create the service account that will be associated with the policy that we created. So here we have a name of our new service account. It's called Dynamo Users. The next is the cluster here. This is December 09. We're also giving it the default namespace. The policy that we're attaching to is actually this EKS Dynamo Users one that we just created in the previous step. Now we just run this, it'll go through, and it'll create it for us. Once created, we can make sure it's there. And you can see the service accounts that we've created. You can see right here that I've commented it out before, so I'll add it back in. This is my Dynamo user service account that I'm adding to the specification of the deployment. Now let's apply this. It'll restart the pods. One of them will stop, one of them will start going. And the new one will actually be part of that service account. At this point, I should be able to refresh my application and see that it has access to the DynamoDB table, and it does. Excellent. So I hope now you understand how you can use service accounts to actually enable your workloads that are running on your EKS cluster to access other AWS resources. And honestly, that's one of the #1 reasons of why you're running EKS on Amazon anyway. Otherwise, you might run Kubernetes somewhere else. So thanks for sticking around, and let me know if you have any questions about it or any other thoughts. Thank you.